All right, let's look at these examples. So we're just adding on more variables. So part A, we have square root of 63 u cubed v to the 5. Let's separate square root of 63, square root of u cubed, square root of v to the 5. Let's see if we can recognize any perfect squares in here. So I know 63 is 9 times 7. Good. 9 is a perfect square. Alright, so this is going to be square root of 9 is 3, and then square root of 7 stays the way it is. Alright, now let's look at the u's. Right, so this is an index of 2. You want something that divides by 2. So we're going to separate them. U to the 2, u to the 1. Then we can do this division. So we get u with absolute value, and then square root of u, which comes from here. Okay. Now let's do the v. So again, we have square root. We need something in here that divides by 2. So biggest number. So this is v to the 4 times v to the 1. Okay, so these divide. We get v squared. And this one square root of v. Okay, so let's kind of gather everything. So we have 3 square root of u. The v squared doesn't need a square root because it has that even power. It's already positive. And inside the radical, we have the 7 and the u and the v. Alright, so this is our final answer. Alright, let's look at part B. Cube root of 40, x4, y5. So separate cube root of 40, cube root of x to the 4, cube root of y to the 5. Alright, do I recognize any perfect cubes inside that 40? 8. Yeah, 8 times 5. So I'm going to write this cube root of 8 times 5. So cube root of 8 is 2, and then cube root of 5, like this. Alright, let's go to the x's. So I need stuff that divides by 3. So I'm going to write x to the 4 as x to the 3 times x to the 1. Okay, then divide this. We get x to the 1 on the outside and cube root of x on the inside. Okay. This one for the y's, I want to separate this as y to the 3 and y to the 2. Okay, so divide these exponents, we get y to the 1, and then we have cube root of y to the 2 left over. Okay, so let's see. We have 2xy all came out, and then we have cube root of 5, cube root of x, cube root of y squared. So all these get lumped together inside the radical. 5xy squared. Like this. Alright. Okay, we have one more to do. Let's scroll this up. So part C, 4th root of 48 x4 y to the 7, 4th root of 48, 4th root of x to the 4, 4th root of y to the 7. 48 is 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. Alright, good. So I can see that I can write this as 4th root of 2 to the 4 times 3. And then 4th root of x to the 4. So these divide, so I don't need to break things up. And then 4th root of 7, we're going to write as y to the 4 and y to the 3. Alright, so we can divide this in this exponent with the index. I get 2 to the 1. fourth root of 3. And this one divides exactly, so x to the 1 with absolute values. There are no x's left inside the radical. And this one I get y to the 1, and then fourth root of y to the 3. Alright, so these go on the outside. These go on the inside. Okay, that was bad. Let's try again. These go on the inside together. So we have 2 absolute value of xy, fourth root of 3y to the 3. There we go.